Okay, here's our lesson 1.3. We're going to be talking about transformations today. I think you've talked about some of the basic transformations before. So when we talk about those, we talk about translations, rotations, reflections, and dilations. And so we're going to still be talking about those, but today I really want to introduce to you coordinate notation, just so you're used to seeing kind of how they write that in geometry sometimes. So let's just focus real quick on some of our basic definitions. So a transformation is a function specifically that's going to change the position, shape, or size of a figure. All right, that's its job, is to change either where the shape is, where the figure is, it's the shape of it, or maybe its size. And there's some vocabulary that goes along with that. So the original figure is called the pre-image. So that's your original figure. And the new figure is called the image. And when we notate that, notice that the pre-image is just written using like a regular letter. But then when we write the image, its new location is written as like A prime. You can kind of think about that, how when you save a document for the first time, you might call it like document A, but if you download it again, I don't know if you remember this, but if you've ever like downloaded something, when you download it the second time, it like makes a copy and puts a little 1 next to it. It's kind of the same idea with these primes. For instance, if we moved this A point again, the next image would be a double prime, right? So each time we move it, or transform it, it becomes a new image. So there are 4 basic transformations that we want to talk about, and we're going to do kind of 3 example problems to explore what those basic ones are and some of this new notation. All right, so here's our first example. We'll call this one example A. You can include this just a rough sketch of this little graph right here. And I've gone ahead and listed out the coordinates for us from the graph. So the problem itself reads, x, y, transforms to be x minus 4 and y minus 3. So literally what they're telling us to do is take the x coordinate and subtract 4 from it. All right, that means my new image for A, so A prime is going to be 0 minus 4, which is negative 4. And my new image for the y coordinate on A is going to be y minus 3. So if I do 4 minus 3, I'm going to get 1. All right, let's do that again for B. So B prime, it says subtract 4 from the x value and 3 from the y value. All right, one more time with C. Subtract 4 from the x value and 3 from the y value. So now I'm going to plot these on top of the same image that I had before and see what happens. So when I did that, notice that my triangle has moved now, and think about the directions that it has moved. I've moved to the left 4. That's because in the x direction I'm subtracting 4. And then my same triangle has moved down 3. So there's a few different things I want us to take notes on about this example. Okay, so what I want us to notice here is that addition and subtraction, and when I say that I'm talking about what we're doing up here with the coordinates, addition and subtraction causes a shift or a translation. So translation is the fancy word for shifting the object. That's like physically taking whatever object we see and just pushing it left, right, up, or down. That's an example of a translation. This type of transformation, a translation, is a type of rigid motion. So rigid motion is something that preserves the size. Rigid means it's like hard, it can't be moved, it can't be changed. So whatever you're doing is not changing the size. And another word that goes along with that is this concept of congruence here. All right, so you just need to know addition and subtraction causes translations. That's an example of rigid motion, and thus congruence. All right, here's our example B. So again, they're giving us instructions in this notation that they've shown us at the top. And that is that we take this very first coordinate, and we're going to change it so that the x becomes negative. And it's not really that it becomes negative, it's that it becomes the opposite of what it was before. So x and negative x, if you think back to algebra, that's kind of like when you did negative b over 2a, right? The that just means you do the opposite of whatever you were given. And then the y is going to stay the same. Notice nothing's happening to the y coordinate there. So let's go ahead and change these. My image now is going to be r prime is going to be positive 4 because the x value changes, but the y value stays the same. All right, s prime then will be 1 and 3. T prime, again, change the x value to the opposite sign, keep the y value the same. So now if I graph these, notice that this time it's not just that my figure shifted. So it's not that I'm taking that triangle necessarily and just moving it to the right. The orientation itself has also changed. So if you can kind of look at that, hopefully you see that this original triangle has flipped to now become that one. Notice that the point T moved a lot farther than just the point S, right? That flip is called a reflection, and it's another type of rigid motion. So let's go ahead and take ourselves a note for that. Notice that that happened because we had a negative value, and that's the only thing that was happening. All we were doing was changing the sign on one of the values. All right, so multiplying by a negative causes a reflection. So we just talked about those two vocabulary words, which is another type of rigid motion, because again, my pre-image and my image end up being the same size. Another note that you may want to make, so notice that when we change the x value, we're only flipping it left or right, which means we're flipping over the y-axis. So that kind of reads backwards, but rewatch that or relook at that if you need to. Negative y, so if we had changed the y values instead, that would have reflected this pre-image over the x-axis instead, and it would have ended up down here in this third quadrant. All right, let's look at our last example together. Okay, so example C here, notice that in the instructions, they're telling me that for the x value, I need to multiply it by 2, right? That's taking x and changing it to 2x. And for the y value, I'm going to be keeping that the same. Okay, so if I work that out, that means my new coordinates are going to be j prime, so multiply the x by 2, negative 2, and keep the y value the same, 2. All right, k prime is going to give me 4 and 2. Last one, multiply the x value by 2 and keep the y value the same. So I'm going to go ahead and plot these and see what's going to happen. Okay, so notice this time, this one's a little bit weird, because when we look here, we see that, first of all, these are not the same shape. I mean, yes, they are both triangles, but these are not congruent to one another. They are not exactly the same shape. So this is not an example of a rigid motion. It kind of looks like a dilation. So a dilation is something that would take the exact same size, but make it a larger version of itself or a smaller version of itself. Think like if you zoom in, on your phone or something, the proportions all stay the same. That's not what this is, because the proportions are not staying the same. Instead, notice that the only thing that has changed are the x values, and they're getting larger. This is an example of a horizontal stretch. Okay, so the note that we want to take here then is that multiplication results in a stretch or sometimes a compression. So a few things. One, this is a stretch because what I'm multiplying by is a number greater than 1. If I had somehow multiplied by a fraction, that would have been a compression because it would have resulted in a smaller number. Also, remember, because I'm dealing with the x, this is called a vertical stretch. If I had multiplied the y value, it would have been a vertical stretch because vertical is in the y direction. The other note that you need to take here is that multiplication is only a rigid motion if, so this is a big if, both x and y have the same multiplier. So if I had multiplied both of these by 2, it would have made the entire figure twice as large in all directions. So it actually would have been the same shape, just larger. If that happens, so 1, it's a rigid motion, and 2, we call that a dilation. Otherwise, this is just called a non-rigid motion. So this example itself, you probably are going to want to write down, is called a non-rigid motion. All right, and if you have those notes, you should be ready for what we're going to talk about tomorrow. We'll do some examples together before we get started.